Hello and welcome back everyone to this new series on Python. This series of videos will help you take your skills from beginner to expert level in Python. Do not forget to hit the red subscribe button and the bell icon so that you are the first one to know whenever I upload any new video. In today's session we will see different data structures in Python. Now let's jump to Jupyter Notebook and get started. Open a new notebook, click on the drop down, click on Python. Now a new notebook will open in a new tab. Let's rename this notebook. Let me rename it to data structures. Click on rename. Now variables, as we discussed in previous videos, will be able to store single value. We define a variable x and we have to assign value 3 to it. Press enter, write down x. Now press shift plus enter to run the cell. So now we can see that value 3 is stored in the variable x. And let me define a new variable, say y equal to python. Press enter, write down y and press shift plus enter to run the cell. Now this string python is stored in the variable y, but when we have to store multiple values in a single variable, then we will make use of data structures. Different data structures that we have in Python are list, then second is tuple, third one is dictionary, and the fourth is set. So whenever we have to store multiple values in a single variable, then we can use either of these four data structures. There are two main properties of these data structures. First one is that these data structures are one dimensional. The Microsoft Excel that you all have seen have concept of rows and columns which are two dimensional, but these data structures are one dimensional. And the second property is that these data structures are heterogeneous. This means that multiple values can be stored in the form of integer, float, pool, and string data type. Let me open a new Excel. Microsoft Excel is two-dimensional. So these all are the columns and these are the rows. And in a single column in Excel we can write two, which is of int data type. Then let me write Python. So this is of string data type, and then let me write down 2.5, and this number is of float data type. So similar to Excel, we can enter values of multiple data types in a single variable. Now let's see how to create each of these data structures. Let me run this cell. Now to create a list, we use square brackets. So let's suppose the name of the list that we are defining is L1 equal to, then within square brackets we can give the values of different data types. Then we have tuple. We can define tuples either by using parentheses or without any parentheses. Let's name the tuple as t1 equal to either within parentheses or simply we can write different values without any parentheses. Next, to create a dictionary, we use curly braces. So let's name the dictionary as d1 equal to curly braces. And lastly, to create set, also we will use curly braces. In today's session, we will be discussing these two data structures, list and tuple. Both these data structures, list and tuple, work in a similar manner, just that there is one difference between both these data structures, which we will be discussing further in this session. Now let's explore list and tuple with few examples. Press Shift plus Enter to run this cell. No need to bother about this syntax error. Now we know that data structures are used to store multiple values. Let's create a tuple, say t1, and assign value 1. Press enter, again write down t1. Press shift plus enter to run this cell. Now you will see that value 1 is stored in this variable t1. Let's see the type of this variable, which many of you can guess will come out to be int. Now let's add multiple values in this variable equal to 1, 2, 3.4, comma, within single quotes we can write down tutorial. Now press enter and again write down t1 and let's run this cell. Press shift plus enter. So here you will see that we are getting all the values within parentheses that we have given to this variable. Let me check the type of t1. Press shift plus enter. So here you can see that t1 is a tuple, and here we will see the two properties of data structures that we have discussed. So first of all, data structures are one dimensional. That means we can give values only in the form of rows. And secondly, data structures are heterogeneous. So here you will see that 1 and 2 are of int data type, then 3.4 is of float data type, and tutorial is of string data type. So data structures are heterogeneous in nature. That means we can add values of multiple data types in a single variable. Now let me create another tuple by enclosing it within parentheses. Let me write down 4, 6.2, within single quotes we will write down hello. Press enter. Write down T2. Press shift plus enter to run this cell. So now we have defined another tuple. Let me check the type of T2. Run this cell, and T2 is a tuple. So we can define tuple either by enclosing all the values within parentheses, or we can also define a tuple without using any parentheses. Also, we have seen that in tuples we can have values of multiple data types. Now let's see how to define list. So let me create a new variable L1 equal to, and within square brackets we will give the values 1, 4, 6.7, within single quotes we can write down list. then close square bracket, press enter, write down L1, press shift plus enter to run this cell. So here we have created a list with values of multiple data types. Let's see the type of L1, press shift plus enter. So L1 is a list. So we have seen how to define both the list and the tuple. Now we will see how to access elements from the tuple or a list. Access values from tuple. Let's first see the output of variable t1. So all these values are stored in tuple t1. Now to get elements from any data structure, whether it is a tuple, list or a dictionary, we will use square brackets. Every element in a list or a tuple has an index associated with it. Index 0 will be assigned to value 1, then index 1 will be assigned to value 2, index 2 will be assigned to value 3.4, and index 3 will be assigned to tutorial. Now if we have to get element 1 from this tuple, we will write down t1 and within square brackets we will give the index. So to get the element 1 we will write down index as 0. Now press shift plus enter. So here you will see that value 1 is returned from this tuple t1. Now suppose we have to get element 3.4 from this tuple, we will write down t1 and within square brackets give the index of 3.4, which is 2. Press shift plus enter and we are able to get value 3.4 from this tuple t1. In a similar way, we can access elements from a list. So we defined a list L1, press shift plus enter. Now we have to get element list from this variable L1. Index 0 is assigned to element 1. Index 1 is assigned to element 4. Index 2 is assigned to element 6.7 and index 3 is assigned to this string list. So let me write down L1 and within square brackets write down 3, which is the index of list string that we have here. Press shift plus enter and we were able to get this list string from the L1. Now you will observe that we don't have any element with index 4 because this is the last element that we have with index 3. So let me write down L1 and within square brackets write down 4, press shift plus enter. So here you will observe that we are getting error list index out of range. So make sure that you are giving the correct index for the element that you want to return from the data structure, whether it's a list or a tuple. So here we have accessed elements from a list or a tuple using positive indexing. You will observe that we have used positive numbers to access elements from a list or a tuple. We also have negative indexing. Now suppose you want to get the last element from this list. So simply you can write down L1 and within square brackets we will write down -1. Press shift plus enter. So now we are able to get this string list from the L1 using negative indexing. So negative indexing starts from the last element and index -1 is given to the last element. Then second last element will be given index -2. Similarly, third last will be given -3 and so on. Now suppose I want to return the second last element from this list, which is 6.7. So simply here I will write down within square brackets -2, press shift plus enter, and I am able to get 6.7, which is the second last element in this list L1. So if you want to get elements from the last, then you can also make use of negative indexing. Till now we have seen how to get single element from a list or a tuple. Now suppose you are interested to get multiple elements from a list, then we will use colon in between the square brackets. So this concept is called slicing. Make sure you remember this term because you will be hearing this term slicing a lot in further videos. So let me write down L1, and within square brackets we have three things that we can give. First is start, then colon, end, colon, step size. So what we can do is, here we can give the index of the first element that we want from the list, then index of the last element that we want from the list plus 1. So here let me write down plus 1. So index of the last element plus 1, and this is the step size. Let's understand this with an example. So press shift plus enter. Now in the new cell I will write down L1. First let's just view the list. Now suppose we want these three elements from the list L1. One is stored at index position 0, which is the start position. So write down L1, and within square brackets write down 0 colon, and we want elements till 6.7. 6.7 is stored at index position 2, so we will write down 2, which is the index position of the last element, plus 1, that gives us 3. Ignore step size for now because this is optional to give. Now let me run this cell to see the output. So here you will see that we are getting elements starting from 1 till 6.7. This simply means that give me elements from the list L1 starting from index 0 and go till index 3, not including the element at index position 3. So we will get elements starting from index 0 till index 2. This might seem a little confusing. So let's see another example. Now suppose we want element 6.7 and this string from list L1. So the index of the starting element, which is 6.7, is 2 colon, then the index of this last element is 3. Here we will write down index of the last element plus 1, that is 4. Press shift plus enter. So now here we are able to get elements 6.7 and this string from list L1. So this simply means give me elements from the list L1 starting from index 2 and go till index 4 and not including element which is stored at index 4. This is easy way to remember this concept. Now you know how to get multiple elements from a list or a tuple using slicing. Let's see another example, L1, and within square brackets, not mentioning anything at start, colon 2. Let's see what happens now. Press shift plus enter. Now if we are not giving anything in the start position, then we are telling Python to return elements from the index position starting from 0 till 2 and not including the element at index position 2. That simply means give us elements starting from index position 0 till index position 1. 1 is stored at index position 0 and 4 is stored at index position 1. Let's see another example. L1 within square brackets, we will give the index position of the start element, that is 1 colon, and what we will do is we won't give anything for the index position of the last element. Let's run this cell and see what output we get. Press shift plus enter. Now Python will return us elements starting from index position 1 till the index position of the last element. In all these examples that we have seen, the step size by default was 1. Let me write down L1, and within square brackets we want elements from the list L1 starting from index 1, and we want elements till index 3. So here we will write down 3 plus 1, which is 4, and colon, we are giving the step size as 1. So let me run this cell, shift plus enter. Now we are getting elements starting from index 1, that is element 4, and we are getting elements till index 3. So these three elements are coming. Now let me explain you the role of step size here. First, we are getting the element that is stored at index position 1, that is 4. The step size is 1, that means increment the index by 1. So now we want the element that is stored at index position 2, that is 6.7. Next, again the step size is 1, so increment the index by 1. 2 plus 1 gives us 3. Now we want Python to return the element that is stored at index position 3, that is this string list. Now suppose we want alternate elements from the list. Say first we want element 1, then next element we want is 6.7. In that case, we will write down L1 within square brackets. The index of the first element that we want from the list is 0. Then we want elements till 6.7. The index position of 6.7 is 2. So 2 plus 1 is 3. That gives us the index position of the end element that we want from the list. Next, we have to mention the step size. Now we want the alternate elements from the list. First we want the element 1, which is stored at index position 0. Then we want the element 6.7 that is stored at index position 2. So instead of incrementing the index by 1, we want the index to be incremented by 2. So here we will write down 2 as the step size. Let me run this cell. Now here you will observe that the first element that we are getting is 1, that is stored at index position 0. Then we want the element 6.7 that is stored at index position 2. So increment the index 0 by 2. 0 plus 2 gives us 2. That means now we will get the element that is stored at index position 2, which is 6.7. So if you want continuous elements based on the start and the end position, no need to mention the step size, as by default the step size would be taken as 1. Let's see two more examples that will give us same results. I want continuous elements from starting index position 0 till end index position as 2. Let me run this cell and let's see what results we will get. When we won't mention any step size, press shift plus enter. So here both the cell gives us same results. In a similar way, you can also get elements from the tuple. Let me run the tuple first. P1. Suppose we want elements starting from index 1 till element 3.4, which is at index 2. So we will write down P1 within square brackets the start index, which is 1, colon, we want elements till index 2, so 2 plus 1, which is 3. Press shift plus enter. So now we are able to get elements 2 and 3.4. Let's see few more examples where we have a tuple within a tuple that makes a nested tuple. So define a new tuple, say t2 equal to 1 comma 2 comma 2. Create another tuple. Here we will write down within parenthesis t.4 comma within single quotes I will write down Python. Now after closing parenthesis comma, let me write down tuple. Now press enter, write down t2 and press shift plus enter. Let me check the type of variable t2. Press shift plus enter. Here we can see that t2 is a tuple. In this tuple t2, index 0 is assigned to element 1, index 1 is assigned to element 2, index 3 is assigned to this tuple. Let's see what we get when we give the index as 2 within the square brackets. Press shift plus enter. So we will get this entire tuple as a single element in the output, which is stored at index 2. Now suppose someone wants to get this Python string from this entire tuple t2. You just observe that writing 2 within the square brackets gave us this entire tuple. Now to get Python from this tuple, what we can do is write down t2 within square brackets, write down 2 and add another square brackets. Now if we consider this tuple, 3.4 is stored at index 0 and this string Python is stored at index 1. Within second square brackets, give the index as 1, press shift plus enter and let's see what output we get. So we were able to get Python from the entire tuple t2 using another square brackets. Next, suppose we want this element 3.4 from this nested tuple t2. So first of all, we need to get this tuple from the entire tuple t2. So write down t2 within square brackets. The index position of this tuple is 2. So write down 2, press shift plus enter. Now to get element 3.4, we will add another square brackets. The index position of element 3.4 is 0. So within second square brackets, write down 0, press shift plus enter. We were able to get element 3.4 from this nested tuple T2. So these data structures are heterogeneous. That means we can have elements of any data type within a single data structure. Let me define another list L4 equal to, and here we will give elements of all the data types that we have studied so far. Within single quotes, write down hello. Then we will give a tuple We know that to define a tuple, we use parentheses. Then let me define a list also inside this variable L4. Jupyter, comma, then notebook. Now press enter, write down L4, press shift plus enter. In this variable L4, we have elements of multiple data types. Let's check the type of variable L4. Write down type of L4, press shift plus enter. Here we can see that L4 is a list. Next, suppose we want to return this element Jupyter from the variable L4. So what we can do is, first we have to get this entire list from the variable L4. So write down L4 and within square brackets we will write the index of this list. We want the last element, so write down -1, press shift plus enter. Now to get Jupyter from this list, write down L4 within first square brackets -1, then add another square brackets. The index of Jupyter in this list is 0. So in the second square brackets we will write down 0, press shift plus enter. So here you will observe that we were able to get Jupyter from the variable L4 using two square brackets. Now in the starting I told you that list and tuple work in a similar manner, just that there is only one difference between tuple and the list. Tuples are immutable and lists are mutable. That means the elements of a list can be updated, but the elements of a tuple cannot be updated. Elements of a tuple cannot be updated. Let's try to understand this with an example. Now let me first see the list L1. Suppose you want to update this element 4 to 8, which is stored at index position 1 in this list. So we want to update element 4 to 8. First of all, we will see how we can get the element 4. Within square brackets we will give the index as 1. Now to update this value from 4 to 8, we can simply assign new value to this element in this way. Now we are assigning value 8 to the element which is stored at index position 1 of this list L1. Let me run this cell, press shift plus enter. Now let's check the output of list L1. You will observe that earlier in the list L1 the element at index position 1 was 4. Now the list L1 has been updated and we are seeing element 8 at the index position 1. Now if you try to do a similar thing in case of tuple, let's first check the output of tuple T1. We want to update the value 2 to 8 in this tuple. Value 2 is stored at index position 1 of this tuple. So within square brackets write down 1. Press shift plus enter to run this cell. Now we are able to return value 2 from this tuple. what we did to update the element of the list. Similar thing we will try to do in tuple. T1 within square brackets we will write down 1 equal to 8. Press shift plus enter to run this cell. Here you will observe that we are getting error that tuple object does not support item assignment. That means tuples are immutable. We cannot update the elements that are stored inside a tuple, but we can update the elements that are stored in a list. That means lists are mutable. So this was all that I had to cover in this session. In this session, we have seen what are data structures, and in detail we have discussed two data structures which are list and tuple. Now in the next session, we will be discussing the next data structure which is dictionary. Thanks for watching this video. I hope this session was helpful. See you in the next tutorial.